Hey guys, sorry that I couldn't be with you today. My daughter ended up getting pink eye and it's contagious, so I need to stay home with her for the day. Um, and I know I've missed a bunch of time, which I'm not happy about that with missing time with you guys. But I thought maybe I could make this video. You could watch it in class, and it would sort of take place of a lesson that we might normally do. And this one isn't too difficult, I don't think so. Hopefully, with a little practice and paying attention, we'll be fine. Okay, so the first thing we want to do here is we want to talk about exponents. And if we're going to talk about exponents, we need to define an exponent. Okay, so an exponent. What is an exponent? Why don't you go ahead? This is going to be the first pause in the video. So why don't you go ahead and pause, take about 30 seconds, and discuss with the people around you what an exponent is, what it looks like, what the different parts are. So go ahead and do that and pause this video now. Okay, well, hopefully you had a chance to look at an exponent. And what we're going to do here is I'll just give you an example of an exponent. So an exponent is going to look something like, we'll do 5 cubed. Okay, so 5 cubed. This part here, the 5, that is called, this here is called the base. Okay, this little guy here, this is the exponent. Okay, now all this means is this is repeated multiplication. Okay, multiplication we do is repeated addition. So when we do an exponent, we talk about repeated multiplication. So what this is saying is I have the number 5, and I'm going to multiply it by itself 3 times. Okay? Well, one of the things we can do with this, which is helpful, is we're going to use this when we start, mainly when we start using scientific notation. We're going to do some math problems with that. We're going to do some multiplying, dividing, adding, subtracting, all that fun stuff with scientific notation. So we need to talk about exponents and make sure you guys understand that. So I'm going to go through this little PowerPoint that I've got made, and it is talking about the rules of exponents. And overall, this should make pretty good sense to you, I think, if you just kind of watch it, pay attention. And I can also share this with you guys, the PowerPoint, if you want, but I think the video should be good enough. Okay, so let's do this. We're going to start off, we're going to talk about, this is chapter 4.5. And what I want you to do is I want you to notice what happens when we multiply 2 powers of the same base. Okay, now don't be freaked out by these variables. Okay, this is just a letter. This is just another letter. They represent a number. Okay, we don't know what that number is, but this A could be a number. Let's say it's 5. This would be 5 to the 4th power times 5 to the 3rd power. Okay, it just really indicates A and this other A, they're the same number. So what they're doing is, if you write this out, if you expand this, you're going to end up with, well, A to the 4th means A times A times A times A. And you're going to multiply that with A cubed, which is A times A times A. Well, since this is just one giant multiplication problem, what you can notice is that there are 4 factors here, there are 3 factors here, which together make 7 factors. So when you are just straight multiplying all these things, you can just add the exponents. Okay? And that's what this says. It suggests a rule for multiplying powers to the same base. But I'm hoping you see that, right? Repeated multiplication. We're just multiplying the same thing over and over again. Okay, so this is what the product of powers property looks like. Okay, same idea. If I take some number and I raise it to the m power, whatever that is, and then I multiply that same number raised to whatever other power or exponent, then I can just add them together. And just what it look like in numbers. 4 cubed plus times 4 squared is equal to 4 to 3 plus 2. So that's 4 to the 5th power. Okay, so let's take a look at Lake Powell. This is a reservoir behind the Grand Canyon Dam in Arizona. So it can hold about 10 to the 12th power cubic feet of water when full. Okay, this is some crazy number. I can't even imagine what that is. I'm hoping you have a pretty decent understanding of what a cubic foot is by now, right? This is a cube with 1 foot by 1 foot by 1 foot in 3 dimensions. You can think of it's kind of like Arthur Square, but moved to the third dimension, right? Spherius would be proud of him. Okay, so let's say there are 10 times 10 to the 27th water molecules in 1 cubic foot of water. How many water molecules can the reservoir hold? Well, this is going to be some obscene, absurd number, because in order to find the total molecules in reservoir, we need the total amount of cubic feet, and we're going to multiply that by the number of water molecules in a cubic foot. So plug in the values, 10 to the 12th times 10 to the 27th, okay? And what I want you to do is go ahead and pause the video, and you tell me, what do you think that this answer is going to be, okay? Discuss with your table. Pause the video now. Okay, well, hopefully you guys notice that 10, right, same base, we're multiplying it. What can we do? Well, we can use the product of powers property, and we can just add those exponents, okay? I'm not going to make you memorize this products of power property. I just want you to know what it does and how it explain how it works. Okay, so you end up with 10 to the 39th power. That is a lot of water molecules. Okay, this is 1 with 39 zeros after it. Again, it's some number you can't even imagine, really. Okay, well, let's see what else we got here. Using the product properties, we're using this product of powers property. Okay, again, one giant multiplication problem. So what you can do is you can use the commutative property, which basically means you can multiply in any order. And we're going to separate this all out. So we're going to 3 times 5 times x to the first times x to the fifth. Now notice, see, this one didn't have a variable or an exponent on it. The x, it means that there's one of them. You're multiplying it by itself one time. Okay, well, I'm assuming that from here you can figure this out. 3 times 5 is 15. X to the first times x to the fifth is going to be, yep, you got it, x to the sixth. Okay? And then multiply, and we get 15x to the sixth power. Okay? Well, if we can do that with multiplying, then there should be some sort of thing we can do when we divide. Okay, so here's another one. We have a to the fifth divided by a to the second. So when you look at this, you write it out, expand it out, a times a times a times a times a, right? The base here is a, my exponent is 5. That means that I multiply a by itself 5 times, a squared, a times a, okay? And now this is a giant division problem. Now, in the process of dividing these, okay, we can cancel some of these out, right? So a divided by a is 1, and another a divided by a is 1. So those cancel each other out, and I'm left with a times a times a, which is a, right? We took the original 5 and we subtract the 2 because we're dividing those out, and we end up with a cubed. Okay, so this is what it's going to look like. Right? Divide powers at the same base, you subtract the exponents. Okay? And whenever you're dividing, you can't have a 0 in the denominator. So this is why they say a is not allowed to be 0. Okay, and here's what it looks like in numbers. If I have 6 to the 8th and I divide by 6 to the 5th, okay, well, 5 of these 6's are going to cancel out with 5 of these 8's, which is why you subtract, and you're left with 6 cubed. Okay, so let's try both of them, right? Simplify this. We have 3m to the 5th times m squared divided by 6m cubed. Well, there's a couple different ways you could do this, but, you know, sometimes it's easier if you just sort of expand it out. Maybe you do 3 times m times m times m times m times m, right? That's the m to the 5th times m all together. And what they basically did here is they simplified up top here. They said, okay, you know what? These are the same base. Let's put those together. So we add the exponents, and we're going to end up with 3m to the 7th over 6m cubed. Well, I'm not done yet because I can still subtract some of these exponents, right? Because I'm dividing. So we'll subtract 7 minus 3, and we'll be left with 3m to the 4th over 6. Okay? And since these are both have a common factor of 3, divide both, and I end up with m to the 4th over 2. Okay? Well, I'm hoping you have a better understanding of this. What I want you to do is take the rest of the class period and work on these these problems, numbers 3 to 39 odd. Okay, make sure you practice, use your neighbors. We're gonna do. There's another section that goes after this, section 4.6, that talks about 0 and negative exponents. So we're gonna combine this 4.5 with 4.6, and we'll have a concept check after that one. Okay, but I will be back before then and be hopefully there to answer questions for you guys and move on forward. Okay, have fun and good luck.